Hi everyone, welcome to Organic Insight. In this particular video, I am going to discuss about IUPAC nomenclature of hydrocarbons. Hydrocarbons can be classified into three major groups. Hydrocarbons can be classified as three groups, that is, first one alkanes and alkenes, and the third one is alkyne. Now, what is alkanes? It is a saturated hydrocarbons that is having a carbon-carbon single bond between the carbon-carbon. There will be a single bond will be there, and in alkenes between carbon and carbon there will be a double bond, and between alkynes, what is alkyne means? Between carbon and carbon there will be a triple bond like this. Regarding hybridization and all, I discussed in the previous video. You can I will give the link in description. Now for alkanes, what is the hybridization over here? It is sp3 will be there, and here sp2, and for alkynes it is sp. Now if we talk about IUPAC nomenclature, it can broadly classified as three groups. First, we'll learn what is the full form of IUPAC. If we learn, this is International Union of Pure and Applied Chemistry, like that. And broadly, it can be classified into three major types. First one is prefix. First one is prefix. The second one is root word. This is root word, and the third one is suffix. This is exact like names of human being, how it is there exactly. Suppose if name is Rakesh Mr. Rakesh M, if it is there, this is prefix we will call, and this one is the root word, and then this initial whatever it is there, we can treat it as suffix. Exactly like that, the organic molecules also have the three types, that is prefix, root word and suffix. We'll discuss one by one based on what thing these things will depend on. Now first I will take it root word. Root word. What this root word will suggest? Exactly how many carbon atom is there in principal chain. I will talk about principal chain as well as secondary chain afterwards. Just for here, in the principal chain, how many number of carbon atom is there in particular molecule? Here I will write it as a carbon length or chain length. I can write here chain length, and here root word. Suppose if a molecule whatever is under observation, if it has having only one carbon atom, then it is having a root word of meth, that is METH, meth. Suppose it is having two carbon, then I can write it as eth. If it is three, then that is prop. For 4 carbon, it is bute. For 5 carbon atom, it is pent. For 6 carbon, it is hex. For 7 carbon, it is hept. For 8 carbon, it is oct. For 9 carbon, it is non. For 10 carbon, it is dec. For 11 carbon, it is undec. For 12 carbon, it is dodec. Like that, it will keep on going. For our level, like up to 10 carbon is more than sufficient to learn. Now we have to remember, suppose if in a carbon chain, if 4 carbon if it is there, if someone asks what is the root word for that, we can able to tell bute is the root word very quickly. Then we can easily we can name the organic molecule. And second one, I will discuss about suffix. Now further suffix has a categorized into two types, that is a primary suffix as well as secondary suffix. What about this primary suffix will do? Means what it indicates? This indicates a linkage type of linkage between carbon and carbon. Suppose first I will discuss about primary suffix. Here, suppose if carbon carbon single bonds only is there, I have to end a name of a compound with primary suffix, that is ane. If suppose carbon and carbon is having a double bond in between, we have to end the name by ene, that is ene. Suppose if carbon carbon triple bond is there, we have to use yne, ine, like this. How we have to remember this? We already discussed the hydrocarbons classification. This is alkane, right? What is the last three word is like words is there, that is ane. Here alkene is there and here alkyne is there. Last three word whatever it is there, we have to take it in account when we discussing about primary suffix. Now we'll discuss about secondary suffix. In this particular video, I am not going to discuss about functional group, but definitely in upcoming videos. For simple overview, whatever I am giving, just I will discuss the secondary suffix, what it will indicates. It will indicates about a type of functional group present in the particular molecule. Functional groups. Suppose if I write it as ROH, what is the functional group over here? That is, functional group is alcohol. If alcohol is there, we have to use a secondary suffix as ol, that is OL. Suppose if it is R and SH is there, what is this functional group called as? This is thiols, correct? And what is the secondary suffix for this? This is as like this, thiol only. We will write it as thiol. Suppose here R C double bond O and here H is attached. This functional group are called as aldehydes. For aldehydes, what is the secondary suffix? That is al, al. Like this, for so many functional group, we will have a secondary suffix. Actually, secondary suffix will tells about a type of functional group present in that particular molecule. I hope a root word as well as suffix in that primary suffix as well as secondary suffix is understood by you people. Now we'll move on to the next thing, that is third one. I will talk about prefix. Okay, here what is this prefix will indicate? Suppose in a carbon chain, if two functional group is there, two functional group is there, one functional group I will take it as a main functional group. Main functional group will be there, and the second functional group I have to treat as a secondary functional group, like that. I will write it as secondary functional group. This main functional group, we have to use a secondary suffix, that is whatever the name will end in, that we have to use this main functional group secondary suffix. If another functional group is there, that is secondary functional group, we have to use a prefix. That is, for example I will give. Suppose in a carbon chain, if we have two functional group, that is alcohol as well as, what is this functional group called as? This is carboxylic acid. Between these two, we will give the priority to carboxylic acid. I will discuss the same thing in future. For just now we are discussing about prefix. I'm just giving an example over here. We have to treat a carboxylic acid as a main functional group. that is we have to use a secondary suffix over here. What is the secondary suffix for acid? That is oic acid, or carboxylic acid also I can use. But in that same molecule, if we have another functional group, that is alcohols, we should use a prefix, that is secondary functional group. We have to use a prefix, that is hydroxy we have to use. Regarding this prefix, I will discuss in details when we are taking example for functional group. For just now, this much is okay. Now I will discuss the rule on which basis we will give a name for a molecule. This is the rule first. First of all, the longest carbon chain in a molecule we have to identify. Suppose here I will take it an example like here CH3, CH2, suppose CH, and here CH3 is there, and here CH2. Further I have CH2 and CH3. Suppose this is the molecule. First of all, what they are telling is we have to find out the longest carbon chain in that particular molecule. Here, if I want to number, suppose if I start from here, I have to count the number of carbons 1, 2, 3. Now, if I go like this, I will end up with only 4 carbon atoms. But if I not count this carbon, suppose if I go like this is 4 and 5, 6. If I count this as the principal chain, this one only become 4 carbon atom. Suppose if I take this chain, longest chain, that is contains 6 carbon atom, here what they are telling is the longest carbon chain is there. This is called as parent chain. It is called parent chain. And in this molecule, what we have to do is, okay, here CH3 group is there, right, like this. Now we have already discussed that this is, we have to take it as a principal chain or parent chain we can call. But what is the name for this group? That is methyl group is there. We have to name it as side chain. This is called as side chain. In this slide we learnt two words. We have to remember that, that is, one is parent chain will be there, parent chain having a maximum number of carbon atom. In this case it is 6 carbon atom is there, and the second one is side chain or branch chain also we can call. It contains only one carbon, that is this one. This is called as side chain over here. What is this group called as? It is called as methyl group. Now we'll move on to the next, or I will take another example. Just bond line formula I will write because it is very easy to draw and time saving. Suppose here I will take it as like this. Here I have to select the parent chain. What we have to do is we have to count the number of carbon atom from one end to another end. Suppose here 4 end is there, 1, 2, this is 3 and 4. We have to go from one terminal to another terminal so that we have to get a maximum carbon chain. If I start from here, here it is giving 1, 2, 3 and 4. From this terminal to this, it is coming 4 carbon atom, right? And here if I take this is 4 and this is 5, and another it is coming as 5 carbon atoms, and here 5, 6, 7 and 8. From this terminal to this terminal I am getting 8 carbon atoms. That means we have to understood that what is the principal chain which contains a 8 carbon atom, that is the principal chain. Now this is the principal chain. Here one methyl group was there before, this one is the principal chain. it contains 8 carbon, and this carbon is there, and this methyl group, whatever this two group is there, it is called as side chains. I hope the identifying the parent chain is understood by you people. We'll move on to the next rule, that is the numbering is done in such a way that branched carbon atoms gets the lowest possible numbers. Now I will discuss this point by taking one example. Suppose here is the molecule. Now this is the simple molecule I have taken over here. In this particular molecule, the same molecule, I will write it over here also, like this, like this. I can name it as from this end, that is from left side to right side, but here I will do as 1, 2, 3, 4, 5, 6 and 7. The principal chain has 7 carbon atom. Same thing over here, that is contains 7 carbon in principal chain. But here what I will do is I will give numbering from this end, that is from right to left. I will give, this is carbon number 1, carbon 2, 3, 4, 5, sorry here 2 I have to write, 6 and 7. Now what is the side chain over here which is attached to 5, number 5 carbon in the first case, and here which is attached to carbon number 3 in the second case. This rule is telling about branched carbon atoms get the lowest possible number between 5 and 3. Definitely we know that 3 is the least number. That's why we have to name in this order only. That's why this rule, whatever the numbering is done in from right to left, it is correct, and this is the wrong way of assigning numbers to particular carbon chain. Now we'll discuss another example. Suppose if I take, okay, like this, if I take, numbering has to done in this case from, suppose if I want to number from this end, 1, 2, 3, 4, 5, 6, 7, 8. But if I number from another end, I will get as, I will represent this by yellow color, 1, 2, 3, 4, 5, 6, 7, 8. We can observe over here, that is the black ink, whatever I written here, that is number 4, we are given in the right order, that is the whatever the numbering I have given from this end, that is in black ink this is correct, and in yellow ink it is incorrect, like that. Then we'll move on to the next thing, that is rule 3. The name of alkyl group attached as a branch are then prefixed to the name of the parent alkyl, alkane, and position of the substituent is indicated by appropriate numbers. If different alkyl groups are present, they are listed in alphabetical order. Suppose I will take a simple example. We have to understand all this rule by taking one simple example. Suppose here we know numbering has to done in this way, 1, 2, 3, 4, 5, 6, 7. Okay, what is, if I ask what is the root word for this, we have to tell about in parent chain how many carbon atom is there, 7 carbon is there. The root word will be hep, correct. I have to write here name, I will represent by hep. Okay, now after root word is there, and afterwards I have to add suffix to this, and here prefix is there. This whatever the sequence is there, we have to remember like this. Here root word I already wrote. What is the suffix between carbon and carbon? I'm talking about primary suffix. Here there is a single bond, that's why I have to add ane. Prefix is what is the side chain, what is the name of this substituent, and what is this position. We have to mention it by 3, and afterwards I have to separate by hyphen. Then what is this group called as? That is methyl. Now we have to add this all the things. We will get the name as 3 hyphen methyl. Without space, we have to write it as heptane. Correct? This is the IUPAC name for this particular compound. But in rule 3, what they are telling is, here branched chain is there on the carbon number 3. That means where the branched chain is attached, that carbon number is also we have to indicate, and what is the side chain attached to that. That is methyl in this case, we have to mention as a prefix. Correct? Suppose here in the next example, I will take a 2 substituent, that is 2, like suppose like this it is there. Okay, like this it is there. I have to identify the principal chain, which is 1, 2, 3, sorry 3, here 4, 5, 6, 7, 8. Now at the 3 position, one methyl group is there, and in fifth position and another alkyl group is there. I have to write, suppose here I will write it as another carbon, that is propyl. This is not ethyl, it is propyl, because it contains 3 carbon, 1, 2 and 3 carbon it is there. How we have to name this is, what is the root word for this? Root word I will write in middle, that is oct. What is the primary suffix? ane. Octane is there. Before that we have to add a suffix, sorry, prefix. In the third position we have methyl group, 3 hyphen methyl. I have to write like this. Again I have to separate this one by hyphen. In the fifth position I have propyl group, propyl octane. And what is this name? We can write it as 3 methyl hyphen 5 propyl octane. Propyl octane. This is the IUPAC name for this particular compound. Now we'll see some of the common name of branched chain. Now I will just denote this first group like this. I can write it like this. Here carbon and hydrogen is attached. Here CH3 is there, and here also CH, that is methyl group is there. How many number of carbon atom is there? That is 1, 2 and 3 is there. What is the root word for this? Prop we can call, but here it is not attached to any other group and it is identical in 2 ways. Here also it is carbon, like methyl group is there, here also methyl. Such group are called as isopropyl group. Isopropyl, and here you can see it as like this group. Here methyl group is there and here also methyl group. This group is called as secondary butyl and isobutyl. Isobutyl like this. It contains a 4 carbon atom, that is 1, 2, 3 and 4, and it is symmetric, correct? We can see identical methyl groups on either side. We will name it as isobutyl, and this molecule we know in SN1 reaction and all, this is tertiary butyl. Suppose here if it is attached to bromine, tertiary butyl bromide, and this is the another side chain which is neopentyl. Pent means what is that? Root word. It contains 5 carbon atoms. Definitely we can see over here 5 carbon atom is there. That's why the name as neopentyl. This is the common name. We can use it in IUPAC name also. It is acceptable. Now we'll move on to the next thing. If 2 or more identical substituent groups are present, then the numbers are separated by commas. The names of identical substituents are not repeated Instead, prefix such as di, tri, tetra, penta, hexa, etc. like that they are using. Now, here I will take a simple example like this. I will take. It contains a two identical side chain, that is, here also methyl group is there, here also methyl group is there. I have to start numbering from this end, so that the whatever the side chain is there, it will get a least number, that is 2 and 3. Here 4, 5, 6. Now, just if we look at only principal chain, we can easily name it as hexane. Correct? It contains 6 carbon atom and primary suffix is ane, that is hexane. We can just look. But what about this side chain? It contains 2 methyl groups, correct? That is identical. What we have to do is we have to number what is the least number for this methyl group is there, that is position 2, and we have to separate by commas, and here position 3 is there. 2 means for 2 what they are using here, di, correct? Here we have to use dimethyl like this. Now what is full, if we want to write a full name, we will write it as 2,3 hyphen dimethyl, without any space we have to write like this, hexane, like this. 2,3 dimethyl hexane is the IUPAC name for this particular compound. Now we'll move on to next example. More example, if we practice in IUPAC name, more we will understand. Here I will write it like this. I will write. Suppose I want to give a number for parent carbon. I have to start from this end. 1, 2, 3, 4, 5, 6, 7. Then what is the IUPAC name for parent chain? It contains 7 carbon, that's why heptane. We already named this, but before that we have to add a side chain as a prefix. The side chain is methyl group. In this case, that is 3 methyl group is there in the position 2, 3 and 4 respectively. That's why we have to add 2, 3, 4. If 3 is there, what we have to use over here? Tri we have to use. That is trimethyl. Trimethyl, and whatever the name of parent chain is there. If we add both of this, we will get 2, 3, 4 trimethyl heptane. Without space, we have to name a IUPAC name. This is the IUPAC name for this particular molecule. Now we'll move on to the next rule, that is the last rule. If the two substituent are found in equal position, the lower number is given to one coming first in alphabetical listing. Here I will take halogens. We know that there are for simple we have to know about 4 halogens, that is fluorine, chlorine and bromine and iodine. What is the suffix or sorry prefix for this? It is fluoro. This one is chloro, and here bromo is there, and here iodo. Like this we have to use. This is for your kind information. This much is enough for halogens in naming IUPAC nomenclature. Now here I am taking two example, sorry only one example with two substituent. Here I will attach this one by chlorine and here is by bromine. We have a two substituent is there in equal position. We can name from 1, 2 like this, or from 1, 2. Then the confusion will happen. From which side we have to start the numbering. Here chlorine will start by the name with the word C. Here it will start by B. In alphabetical order, B will come first. That's why I have to start numbering like this. This carbon has to get priority 1 and this one as priority 2. Then what will happen to this? Here in second position, in the first position, bromine is there. That's why I have to write 1 bromo. Then again I have to separate by hyphen 2 chloro. What is the root word and what is the IUPAC name for parent chain? This is the parent chain over here, which contains only 2 carbon, that is ethane. Here we should not separate hyphen, just we have to write like chloroethane. 1 bromo 2 chloroethane is the IUPAC nomenclature for this particular compound. I hope this lecture is useful for you people. With functional group and all, I will discuss in the next upcoming videos. Thank you very much for watching.